So we saw this definition earlier. You can copy it again into your notes if you like. But what we're going to do now is we're going to take this definition where a is assumed to be a constant, and we're going to replace a with the variable x, and thus obtain a function. So let's do that now. So, as you can see, the a has been replaced with an x, and just as f of x is a function, f prime of x will also be a function. Now let's investigate this function with an example. So we will find f prime of x for this function given here. So let's give it a try. So I use my definition. F prime of x is limit h goes to 0. And I need, this is the tricky one right here, the f of x plus h. So why don't I do that last? I'll put my h in there, that's easy. Put my minus sign in there, that's easy. F of x is given, so I can just pop that straight in. Now, what is f of x plus h? Well, if this is f of x, then f of x plus h is obtained by merely, let's clean this up a little bit. To find f of x plus h, I merely take this expression, and everywhere I see an x, here and here, I replace it with x plus h. Okay, so it's not fun to look at it, but that is what it is. Okay, so this guy goes here. And I will try to simplify this expression. Now, how do I do that? Well, I can only see one option. I have to do a common denominator upstairs. I have to do something, because if you check by plugging in h equals 0, you're going to get a limit of the form 0 over 0. So that is a problem that I have to resolve. So common denominator here, which will be the product of these two denominators. So if you're doing like 2 over 7 minus 3 over 4, you know, the common denominator would be 28. And you would go 4 times 2 is 8, minus 3 times 7 is 21, right? So I'll do the same thing here. I'm making a big expression. So I'm going to have this times this. First of all, be a bit careful here. I want to make sure my division lines are arranged properly. You know, this one should be longer. So I've got x plus h plus 1 times x plus 2 minus x plus 1, x plus h plus 2, all over the product of this and this. Okay, so now I'm going to expand this numerator here and hope for the best. So perhaps before I do that, I should take this h here, and what's what's going to happen? Well, I think of it as this h being h over 1. And then I have a fraction divided by a fraction. So what do? You flip and multiply. So I end up having 1 over h over here. So you see this h multiplies my denominator there. Anyways, what I'm going to do is just do a little arrow here just to indicate my h moves up there. And my h is there now. Okay, so I've done my thing in red here. Now this awful thing, I will just expand it out. What do I get? So over here, just expanding, I get x squared plus this. So the first multiplication ends up here. And I got a minus, so I automatically just put a bracket in here. It's going to be important. And now I'm doing this product. Trying to not make a mistake, but we'll see. Okay, I have a quick look at that to make sure it's okay. Just quickly redoing this in my head. Hx, 2h, x plus 2, okay. Square brackets. Good job, Jordan, good job. Okay, I'm satisfied. So what happens upstairs? Hopefully some cancellations. Let's get my green. X squared cancels x squared. Here I have xh canceling this guy here. What else? Oh, 2x. Use a squiggle there. 2x, 2x. Oh, this x cancels this x. So all kinds of good things are happening here. 2 and 2. I think that's all I can do there. So what survives? I got 2h minus h. So just giving h on top. And that makes me a happy camper because this h is going to cancel this h. And we will be off to the races. Et voila. Boom. Now, if you come to this stage and your h's are not canceling, then you've made a mistake up here. Almost certainly. There's some mistake. Good thing to keep in mind. Okay, so this was 0 over 0, but now it is 1 over, well, something. So there's no more weirdness here. I can just go ahead and plug in h equals 0. And I get x plus 2, 1 over x plus 2 squared.